Finding the Daughters of Eve. 2025 had only 36 days left. Miss Tarter once said that this was supposed to be the big year, if all calculations were correct. She was 16 years old, barely hanging on, devastated by standardized education and fake adults. She felt all she had left in her was one final question. Where are the Daughters of Eve? She was going to unwind the Milky Way, to find the other solar systems that coalesced during the Coatlicue's collapse. Her mission is to increase the probability of SETI finding a signal. Her only break is that the sister suns would have a similar chemical signature. School and adults were suffocating, parading their failures like some achievement, showing their greatness by dressing up their failures. Culture was moving backwards. She was headed in the other direction. The computer lab. First simulations. The billion progenitor stars that lived and died before the sun was born wept in their remnants, scattered their grief across the interstellar medium, and waited. They waited in silicon carbide crystals, in nanodiamonds carrying xenon signatures, in graphite spherules with extinct titanium-44. For someone to read the message they wrote in isotopes. 4.5 billion years. They waited for her. She sat in the back of the computer lab. Last row. Last machine. The one with the flickering monitor that nobody wanted. The teacher was explaining how to make a pie chart in spreadsheet software. This was information technology. This was the future they were preparing for. On her screen, hidden behind a minimized window, an SVG canvas held 3,000 points of light. Each one a star, each one positioned according to the right ascension and declination from the Gaia DR3 catalog. She had parsed the data herself, written the JavaScript herself, plotted the galactic coordinates herself. The teacher saw her screen. That's not assignment! I know, I'm modeling stellar kinematics. I'm trying to reverse the trajectories of solar-type stars to find... I don't care what you're trying to do. The assignment is pie charts. But I already know how to make pie charts. I've known since I was 9 years old. I'm trying to find the sun's siblings, stars that formed in the same open cluster 4.6 billion years ago. If I can model the tidal disruption and the differential rotation of the galaxy, You're not following directions! The grade was 0. In physics class, she asked about the S process and R process nucleosynthesis, the slow and rapid neutron capture that build elements heavier than iron in the cores of dying stars. The teacher said that this wasn't on the test. She asked about metallicity gradients in the galactic disk and how they constrain where the sun could have formed. The teacher said she was trying to show off. She wasn't trying to show off. She was trying to understand why barium and yttrium abundances could serve as chemical fingerprints. She was trying to understand why HD 162826, the first confirmed solar sibling, had been found only 110 light-years away in Hercules. when the models said our siblings should be scattered across thousands of light years by now. She was trying to understand why nobody else seemed to care that we had family out there. The teacher, in his total fucking uneducation, marked her down for not showing work and a problem that she had solved in her head because she had a perceptual framework for it, because she was actually learning for real. In the cafeteria, she sat alone. She was drawing orbital paths on a napkin, epicycles within epicycles, not the wrong Ptolemaic kind, but the real kind, the way stars actually move when you're in a rotating reference frame. The galaxy doesn't just spin. It has spiral arms that are density waves. Stars speed up when they enter an arm, slow down when they leave. Over billions of years, an open cluster gets sheared apart by differential rotation. The inner stars orbit faster than the outer ones. The whole family stretches into a stream, then disperses into a general stellar population. She was trying to figure out how to run time backward. A classmate knocked her tray off the table. Freak. She picked up her napkin. The orbital paths were smeared, but she remembered them. Her simulation grew. Nights at home, she added perturbations from giant molecular clouds. She added the bar at the galactic center, the way it torques the inner disk. She added radial migration, the process by which stars drift inward or outward over time, trading angular momentum with spiral arms. And eventually, she called her program Coatlicue Children, as it was more appropriate than Daughters of Eve. The code was ugly and beautiful. Functions named Calculate Galactic Potential and Integrate Orbit Backward, a numerical integrator she had taught herself from a paper she found on Arxiv, SVG circles drifting across the screen, hairline trajectories tracing their paths through simulated eons. She would select a star, HD 162826, the known sibling, and run time backward. She would watch it drift toward the sun. Then she would add candidate stars, the ones with the right metallicity, the right barium to iron ratio, the right age estimates. She would see which ones converged. Most didn't. Some came close. She kept a list. Her chemistry teacher told her that her question about isotopic anomalies in presolar grains was off topic. Her math teacher told her that her use of numerical integration was not the method we're teaching. Her guidance counselor told her she needed to focus on her grades if she wanted to have a future. Failing high school meant that she wasn't going to have options. What options? The options to forget? The options to make pie charts for 40 fucking years of her life? The options to pretend that the universe was not calling to her every night through her flickering monitor? She tried to explain once to her mother. There was a star, she said, 30 times the mass of the sun. It lived fast and it died young, maybe 10 million years. That's nothing in cosmic time. When it died, it exploded, and the shockwave compressed a nearby cloud of gas and dust. That cloud collapsed. And from that collapse, hundreds of stars were born. One of them was the sun. Her mother nodded, not understanding. The exploding star that triggered our birth, they named it Coatlicue, after the Aztec goddess, the mother of the sun. Mother of gods, goddess of earth, nature, fertility, life and death. She's dead now. She's been dead for 4.5 billion years. Maybe she left a black hole. Maybe she left nothing at all. But her children are still out there, scattered across the galaxy. I'm trying to find them. Her mother said, "That's nice, honey. Did you finish your homework?" Coatlicue.
Dead mother. 30 solar masses of hydrogen and helium, of carbon and oxygen and silicon and iron, of all the elements your own mothers made, the 1,000 generations before you. Did you know? When your core collapsed, when the iron ash fell inward at 1/4 the speed of light, when the neutrinos screamed through your mantle, when your outer layers blew outward in a light that outshone the galaxy, did you know you were making us?
Did you know that in 4.5 billion years a girl would sit in a dark room with a flickering screen, trying to find her ants among the stars? She is failing her classes for you. She is alone in the cafeteria for you. She is crying on the walk home for you. Watch over her. She is the only one looking. The teacher called her parents. There was a meeting, words like attitude and not applying herself and potential she's wasting. She sat in the chair and said nothing. What could she say? That she was trying to reverse engineer the trajectories of 400 billion stars? That she was trying to find the sisters of the sun? That somewhere out there, maybe around a star that shared our chemical signature, there might be a world, and on that world, there might be someone looking back. They would have said she was deflecting. They would have said she was avoiding accountability. They would have said she needed to focus on what matters. As if pie charts matter. As if anything they were teaching her would still matter in 100 years, in 1,000 years, in the billion years the galaxy takes to rotate once. She walked home in the November dark. Orion was rising in the east. She found Vega overhead, impossibly bright, and traced from there to the constellation Hercules, dim, hard to see in the light-polluted sky, but there, somewhere in that patch of darkness, HD 162826 was shining. A star 15% more massive than the sun. A sister who had drifted 110 light years away over 4.5 billion years of galactic rotation. If you could run the time backward, really backward, not just in simulation, you would see them converge. The Sun and HD 162826 and hundreds of others drawing together, falling back into the natal cloud, unmixing from the galaxy's stellar population, collapsing back into the cold, dense clump that Coatlicue's death had compressed. She couldn't run time backward for real, but she could run it backward in code. She could find the others. If they would just let her. The tears came and she let them. Above her, the winter stars burned. Below her, on the sidewalk, in the cracks, in the soil, in every handful of earth on this planet, pre-solar grains, nanodiamonds forged in supernovae, silicon carbide crystals condensed in the winds of red giants, graphite spherules carrying the isotopic signatures of stars that died before the sun was born. The billion progenitor stars had sent their message forward in time. Tiny crystals drifting through the interstellar medium, incorporated into the molecular cloud, surviving the collapse, surviving the accretion disk, surviving the formation of planets, raining down on Earth for 4.5 billion years. We were here, the crystals said. We lived and we died and we made the atoms in your bones. She wiped her eyes. Tiny diamonds and silicon carbide crystals in her hair. 36 days left. She kept working. We are not alone.